Okay, I want to give you some help on this homework problem from page 404. This is section 7.7, and as you can see, we're going to look at number 22. I usually have some requests for this. It looks a little different than what we're used to. I want to give you two different ways of going about this, and then I'll let you decide if you should happen to see something like this in the future. You've got two different options. You pick the one that you feel the most comfortable with. So let's first of all look at this way of approaching this problem. I'm going to turn this around into more familiar terms. It almost looks like vertex form. Just making the x term come first, so now that looks a little bit more familiar for us. Now we're going to have to draw on something, and you've probably forgotten this, and that's okay, but I'm going to draw on something that we learned way back early on in first semester when we were talking about finding the vertex of an absolute value function. And I gave you this little formula that helped you find the vertex for those absolute value functions. And it was the opposite of b over m would be the x coordinate of the vertex. And then we call this number c would be the y coordinate. Okay, so relating this little formula to my quadratic function here, m would be the number in front of x, 3 will be my b, and then this number outside of the parentheses would be c. So this is a nice way of finding the vertex, and we don't have to do a lot of extra calculation. It would look like this. So our vertex, using this formula, will be the opposite of b, which is 3 over m, which is -2, and then the c number in this case will be -1. Well, the opposite of -3/2 is +3/2, and then of course the y coordinate will be -1. So that helps us with the vertex. So it's from the origin we would go right 1.5 and then down 1, and our parabola is a quadratic, so it's going to be a parabola, will open up from that point, because the a number, a is always this number in front of the parentheses. Well, there is no visible number, so it's understood to be +1. So since it's positive, our parabola opens up. We have a minimum at -1. Now let's just go ahead and build the rest of our parabola from there. So let's do some inputs. I'm going to input 1. That's pretty close to my AOS of 1.5. So let's see what we get. Let's do a little input-output table. What do we get as an output? And you can put into either one of these. It doesn't matter. I'm just going to go all the way up to the red. If x is 1, then 3 minus 2 is 1. 1 squared is still 1, and 1 minus 1 is 0. So for an input of 1, I get an output of 0, and because of my symmetry line, I'm going to have another point at 2, 0. Okay, well let's do another input. 0 is pretty nice. I don't have a y coordinate for input 0, so let's let x become 0. And if I do, that means 3 minus 0 in the parentheses. It's 3. 3 squared is 9, and 9 minus 1 is 8. So I'm going to plot the point 0, 8. And then here's my symmetry line. So same distance away, that's 1.5 to the left, so I'm going to go 1.5 to the right. And connect those 5 dots, and this is the graph of the function that's given in your homework, which is there y equals the quantity 3 minus 2x squared minus 1. Okay, well, the book says to graph the relation and its inverse. Well, graphing the inverse is really pretty easy because all I'm going to do is take each one of these 5 points and I'm going to switch places with the XY coordinates. And after we plot those and connect the dots, we'll be done. Okay, so let's take, for example, this point on the red graph is 1.5, -1. So I'm going to plot -1, 1.5. Okay, this point on the red graph is 1, 0. So on the blue, I'm going to do 0, 1. This is 2, 0. So plot 0, 2. Okay, way up here is 0, 8. So for the inverse, you're going to plot 8, 0. And over here, this is 3, 8. So you need to plot 8, 3 for the inverse. And so these blue dots that'll be connected, this skinny parabola that is opening to the right, will represent the inverse of this given relation. So that's your final answer for number 22. I hope that helps. Oh, I told you I was going to give you an alternate way. We won't work all the way through this, but you could, if you don't want to remember the opposite of B over M and C, and I get that, sometimes that's hard to remember, you could always square this out. And here's what it looks like. If you just wrote this down twice and used FOIL, you would get the following. And then don't forget the -1. And then putting it in standard form, it would be 4x squared minus 12x plus 8. And then remember how we graph, how we find the AOS from standard form, the opposite of B over 2A. You still have to remember that. So if you do the opposite of B over 2A, the opposite of -12 over 2 times 4, which is 8, and that ends up being the opposite of 3 over 2. So you could do it either way. You could go ahead and square this out and put the equation in standard form, remembering how we find the AOS this way, or you could remember how we found the vertex from back in first semester. So whichever way you decide, it really doesn't matter. Once you find the vertex, then I think you should understand how to get the other points on the parabola. And it's very important how to understand or how to come about getting the graph of the inverse by switching the XY coordinates. All right, hope that helped. Shoot me an email or come see me in academic support if you have any questions.